Have you ever wondered what makes up everything around you, from the air you breathe to the food you eat? What if I told you that every single thing in the universe is made of just a handful of building blocks, and they all fit together on a special chart? Welcome to the fascinating world of the periodic table of elements. This incredible chart isn't just a collection of symbols and numbers, it's your gateway to understanding the elements that make up our universe. It's like a secret code that unlocks the mysteries of chemistry, helping you discover how elements interact and why they behave the way they do. How they react with other elements to combine and form the substances that make up everything in our lives. At first it might seem complex, but with this simple guide, you will start to learn the basics and get a true understanding of the periodic table. So what is the periodic table? The periodic table is like a map of all the known elements in the universe. It organizes elements based on their atomic number and shows us how different elements interact and behave. Elements are substances made up of the same type of atom. Iron only contains iron atoms and gold only contains gold atoms. The atom is the smallest piece of an element that we can have and still have the characteristics of that element. For instance, an atom of iron is the smallest piece of iron we can have and still have the element iron. The periodic table of elements is a way to organize these elements according to the properties of their atoms. Elements are listed according to their atomic number that we will learn about in the next section. They are also organized into rows and columns according to their properties. Each element of the periodic table is listed in a box with some important information about the atoms of that element. The first thing you might notice is the larger letter or couple of letters in the center of the box. This is the elemental symbol. This is the abbreviation for the element's common name, which is usually printed just below the symbol. Next, there is generally a number found either right above the symbol or in the upper left corner of the element's box. This is the atomic number. Below the element's common name, you will find the element's mass number. Both the atomic and mass numbers give important information about the atoms of the element. The atoms of each element contain a unique number of protons. If the number of protons changes, the properties of the atom change, and therefore, the type of element changes. All oxygen atoms have the same number of protons, and all iron atoms have the same number of protons. The number of protons an atom possesses is called its atomic number. When you see elements listed in a periodic table, they are in order of their atomic number. For instance, the element oxygen has 8 protons in its nucleus. Therefore, its atomic number is 8, and it is listed 8th on the periodic table of elements. When we know the atomic number of an element, we not only know the number of protons an atom possesses, we also know the number of electrons. The number of negatively charged electrons is the same as the number of positively charged protons. For example, since we now know that oxygen has 8 protons in its nucleus, we also know that oxygen has 8 electrons orbiting that nucleus. Okay, so what is the mass number? A simple definition of the mass number is the number of protons plus the number of neutrons, since it is the neutrons and protons that give an atom its mass. Electrons are so small that they do not contribute to the mass of an atom. However, this definition is not completely accurate. While the atomic number of an element is always the same, the mass number of an element differs among individual atoms. Sometimes, an atom might have a different number of neutrons than another of the same type. This will give the atom a different mass. These same type atoms, with different numbers of neutrons, are called isotopes. We will learn about isotopes in a later video. The video on isotopes will further explain the rather random-looking mass numbers found on the periodic table. The periodic table is divided into two main components: periods, or rows, and groups, or columns. Periods. These are the horizontal rows of the table. Each period represents elements with the same number of electron shells. As you move from left to right across a period, the atomic number increases, reflecting the addition of protons and electrons. Groups. These are the vertical columns. Elements in the same group have similar chemical properties because they share the same number of valence electrons. Electrons in the outermost shell. This gives them similar reactivity and bonding characteristics. A question you may be asking yourself is, why are the lanthanide and actinide series separated from the rest of the periodic table? Lanthanide and actinide are separated from the main body of the periodic table because of how electrons get filled up. We will cover this topic in a later video in more depth. Another reason for placing them below the main body is that they fill up too much space, and for the simplicity of printing on a standard letter size paper. Take a look at how long the periodic table is, if shown correctly. The periodic table categorizes elements into three main types: metals, non-metals, and metalloids. Each category has its distinct properties that make it unique. Metals. Metals are found predominantly on the left and center of the periodic table. Metals are shiny, luster, malleable, can be hammered into thin sheets, and excellent conductors of heat and electricity. Examples of metals include iron, gold, and aluminum. Metals are used in a wide range of applications, from construction materials to electrical wiring. Non-metals. Non-metals are located on the right side of the table. Non-metals lack the metallic qualities of luster and conductivity. They tend to be brittle in solid form, and are poor conductors of heat and electricity. Examples include oxygen, nitrogen, and carbon. Non-metals are essential for life processes, such as oxygen for respiration and carbon in organic compounds. Metalloids. Metalloids are found along a zigzag line between metals and non-metals. Metalloids exhibit properties of both metals and non-metals. For example, silicon is a metalloid known for its semiconductive properties, making it crucial in electronics and technology. Metalloids are valuable in the production of semiconductors, essential in the electronics industry. We will delve deeper into the periods and groups in a dedicated video. There is a whole video's worth of information about the fascinating way the periodic table is constructed. We hope you enjoyed this video and managed to learn a few things along the way. Tune in to the second part of the series where we will be looking at atomic structure. Many thanks for tuning in, and please consider subscribing to help us grow.